everyone. My name is Ode Godwin Daniel and I'm your tutor for today. Please do help to subscribe and follow us across all social media pages at Gordon School of Mathematics. In our last class, we looked at the topic area and volume of a cylinder. And we said that a cylinder has three parts: the top circular surface, and then the base circular surface, and its curved surface. Now, we also said that the total surface area of the cylinder is the sum of the area of the three surfaces. That is, the sum of the area of its top circular surface. Remember, this area of a circle is what? Pi r squared. Then plus the area of its base circular surface, which is also pi r squared. So if we have pi r squared plus pi r squared, that gives us 2 pi r squared already. Then plus the area of its curved surface, and that is what? 2 pi r h. So the area, the total surface area of the cylinder is equal to 2 pi r squared plus 2 pi r h. Now, today we are looking at the topic area and volume of cone, right? Now, unlike the cylinder, the cone has two surfaces. It does not have a top circular face. It only has a base that is circular and its curved surface. Now, such as this. Right? It has the base, which is the base circular piece, and then it curved surface. Right? Now, the total surface area of this cone is the area of this base circular piece and plus the area of this curved surface. Of course, we know that the base circular face, the area of the base circular face is what? Pi r squared, right? So this is settled. Of course, plus, which is the base of the curved, the area rather, area of the curved surface. Now, remember that when we detached the hollow parts, that is the top circular face and the base circular face of a cylinder, that was when we add the net of the cylinder. So we said that the net of the cylinder is the shape you get when you detach the hollow, the circular faces. The same thing, the net of this cone is the shape that you get when you detach the base circle. Now, this part is called the slant height of the cone. Of course, the slant height of the cone. And remember, the radius of a circle is the distance from the midpoint of the circle to any part of the circumference is the radius of the circle, which is the base circle, right? Now, the height of this cone is the distance from the top of the cone, right, to the bottom of the cone, which is the height. Now, if you look at this shape, we already formed a right-angled triangle from this shape. Because sometimes you might be given the height of the cone, you might be given the radius of the cone, but you are not given the slant height of the cone. Now, it becomes your responsibility to first find the slant height of the cone. And how do you find the slant height of the cone? You find the slant height of the cone using Pythagoras rule, right? Now, remember that Pythagoras rule states that the longer side of the right angle triangle, which is hypotenuse square, is equal to the sum of the square of the two other sides. Now, the hypotenuse is the side that is facing the perpendicular angle, which means that our slant height in this shape is the side facing the perpendicular angle, which is also the longest side of the triangle, is the what? Hypotenuse. So, to find the slant height of this triangle, we know that L square is equal to the sum of the two other sides, which is the height and the radius, then plus R square. So that if you take square root of both sides, we have L equal to the square root of H square plus R square. That is how to find the slant height of the cone. Now, to find the area of the curved surface. Now, if you get the net of the cone, that is, when you detach the base circular face from the cone, what you have is the net of the cone, which is the curved surface of the cone. In our last class, the curved surface of a cylinder, when stretched, gives us a rectangle. Now, the curved surface of the cone, when stretched, gives us a shape like this, which is an arc of a circle. That is, we have something like this. We have something like this. An arc of a circle, that is not a full circle, a part of a circle. That's when we remove this circular part of the circle of the cone, and we have just this part that is a curved surface. It becomes, when we open it, tear it and stretch it, it gives us a shape, and it gives us an arc of a circle. Now, if this is an arc of a circle, remember, these two sides are the what? Slant height, right? And this is its angle, which is theta. It means, now, if we have the full circle shaped out, we know that the total angle in a circle is 360, right? Now, the portion of this arc out of the full circle will be theta over 360. Now, if theta over 360 is the portion of the arc out of the full circle, now we can find the curved surface area of this arc. Now, the area of the full circle is pi r square, but then this is the midpoint of this circle. It means that this midpoint to this circumference is the radius. So which means that the radius in this curved surface is not r but L, which is the slant height. So we have the full area of this circle is pi L square, right? Which means that if the full area of the circle is pi L square and the portion of the arc is theta over 360, it means that the portion of the area of the arc, which is our curved surface area, will equal to what? Theta over 360 of pi L square, the full portion. So it means that the curved surface area of the arc, which is the cone, which is the curved surface area of the cone, right, which is the portion of this arc, will be theta over 360 out of the full area of the circle. Because the full area of this circle is pi L square. But we are only concerned with the area of this part of the circle. And we know that this part of the circle already is theta over 360, right? Now, it means that the area of this little part from the circle, which is theta over 360, will be theta over 360 out of the full area of the what? Of the circle. So, in other words, the curved surface area of a cone will equal to what? Theta over 360 of pi L square, which is the same thing as theta over 360 times pi L square. In a situation where the angle of the arc is given, right, you can use this formula to find the curved surface area of the cone. But sometimes, most often times, the angle of the arc is not given. What we have is the radius, which is the radian. Now, note this, that the cone, which is the curved surface area rather, is built on the base surface area. Now, which means that the length of its base circle is equal to the length of the arc. Now, how do we get the length of this arc? Of course, if the base circle, this is radius, right? The length of the base circle, which is its circumference, normally is 2 pi r, right? So we say that the length of its base circle, which is 2 pi r, is equal to the length of the arc. How do we get the length of the arc? Already we have the arc like this, right? And this is theta. If this is the full circle, this is slant height. Now, remember that the portion of this arc is theta over what? 360. The total length of this full circle normally is 2 pi L, right? L as the radius, which is our slant height. If the total length of this circle, which is the circumference of this circle, is 2 pi L, it means that the length of the portion of this arc, that is the length of this arc, out of the full circle will be theta over 360 of 2 pi L, which is the same thing as theta over 360 times 2 pi L, right? Now, we know that the length of its base circle is equal to the length of the arc, in which the length of the arc, the length of its base circle, which is 2 pi r, is equal. We now know that the length of the arc is what? Theta over 360 times 2 pi L. So in a situation where we are not given theta and we were given radius, now we want to make radius the subject of formula so that we can find radius, right? Now to find radius, we divide both sides by 2 pi. So that we have, if this is 2 pi r, we divide it by 2 pi equals theta over 360 times 2 pi L divided by what? 2 pi. So this will cancel out this. This will cancel out this. We have r equal theta over 360 times L, right? So we can just bring it together and say this is theta L. Our radius is equal to what? Theta L. That's our L being the slant height over 360. Now let's come back to the area, the curved surface area of a cone. So if the curved surface area of the cone is equal to theta over 360 times pi L square. Now L square is the same thing as it's the same thing as L times L, right? So we can rewrite this to be theta over 360 times pi times L times L. So now we can also rewrite this so that the one of the slant height will come to theta. We have theta L over 360 times pi times L. Okay, it's still the same thing. So that L times L will still give us L squared. We will still have theta over 360 times pi times L squared. Right? So I've not done anything different. Okay, now we now have theta L over 360 times pi times L. Now recall that our radius R is equal to theta L over 360. What do? We solve for R in the original formula, in the formula, so that we have that the curved surface area of the cone is theta L over 360 times pi times L, right? Where theta L over 360 is the radius. So instead of having theta L over 360 now, we have R times pi times L. If I rearrange this is the same thing as pi R L. So for every time you are asked to find the curved surface area of a cone, the formula is pi R L. That is pi times radius times slant height. Now, in a situation where the angle of the cone of the arc is given, the curved surface area of the cone will be theta over 360 times pi L square, right? Now, if the curved surface area of the cone is pi R L, and then the base circular area is pi R square, it simply means that the total surface area of a cone is equal to pi R square plus pi R L. Now, volume of cone. We know the volume of a cylinder is the area of its base circular surface times its height. The volume of the cone is also the area of base circle times height, but then divided by 3. The area of the base circle is pi R square, then times h divided by 3, which gives us pi R square h over 3. So, we know that the formula for finding the base circular surface of a cone is pi R square. The formula for finding the curved surface area of a cone when the angle is given is theta over 360 times pi L square, where L is the slant height. Now, the curved surface area of a cone when radius is given, the angle not given is pi RL. So it's, in other words, the total surface area of a cone is the sum of the area of its base circular surface and its curved surface. And that gives us pi R square plus pi RL, where R is the radius and then L is the slant height. Whereas the volume of the cone is pi R square H divided by 3. Okay, so we have an example that says calculate the curved surface area, the total surface area, and volume of a solid cone of radius 6 centimeter and slant height 10 centimeter. Take pi equal 3.14. Now, every time you are given a question like this in Word, the first thing you want to do is to write out the parameters that are given, so you will know the appropriate formula to use. Now, from the question, solution. We're told that the radius, which is R, is equal to what? 6 centimeter. The slant height, which is L, is equal 10 centimeter. And we're given pi to be equal 3.14. Now, A, the curved surface area, when radius is given, is pi RL. That is the multiplication of pi with radius and the slant height. Now, we already given that pi is 3.14 times radius is 6 times slant height is 10. right? So we do the multiplication. 6 times 10 is 60. So we have 3.14 times 60, right? So 0 times 4 is 0. 0 times 1 is also 0. And 0 times 3 is also 0. 6 times 4 is 24. Write 4, carry 2. 6 times 1 is 6 plus 2. We have 8. And 6 times 3 is 18. And that gives us, if we sum it up, we have 0, 4, 8, 8, 1. Now, there are two numbers after the decimal point. So we'll move our decimal point backward twice. And this gives us 188.4, which means that the curved surface area of the cone is 188.4 centimeter square. That's very easy, right? Just know the formula that you have to use. The curved surface area of a cone is given by pi rl, right? While the total surface area of the cone is the sum of the base area, which is pi r square, plus the curved surface area, which is pi rl. So we know that TSA, total surface area, is equal pi r square plus pi rl. Okay? Which we have, pi is 3.14 times radius is 6 square, then plus, we already know that pi rl is 188.4, right? So this gives us 6 square is 36. This gives us 3.14 times 36 plus 188.4. Now, let's multiply 3.14 by 36. We have 3.14 multiplying by 36. 6 times 4 is 24. And we have 2. 6 times 1 is 1. Is 6 plus 2. We have 8. 6 times 3 is 18. 3 times 4, 12. We have 2 carry 1. 3 times 1, 3 plus 1, 4. Then 3 times 3 is 9. So we have 4. 8 plus 2 is 10. 1 plus 8, 9. 9 plus 4 is 13. 1 plus 1, 2. 2 plus 9 is 11. Now we have two numbers after the decimal point. So we have to move our decimal point backward 2 times. And that gives us 113.04 plus 188.4. If you sum it together, 0.4, we have 4, 0 plus 4, 4. 3 plus 8 is 11, 1 carry 1. And then this is 10. Remember 1, 1 plus 1, 2 plus 1, we have 3. We have the decimal point. So we have 301.44 centimeter square. Alright. So we've been able to find the curved surface area to be 188.4 centimeter square, and the total surface area to be what? 301.44 centimeter square. See, we're asked to find the volume of the cone, right? And the formula to find the volume of the cone is equal to pi r square h over 3. Now, if you look at the parameters given, we were given pi, we were given radius, but we were not given height. Now, which means that for us to find the volume of the cone, we must first find the value for the height. Now, if this is the cone, right? So, this is its radius, r, which is 6. This is the height, which we were not given, h. We were given the slant height to be what? 10. Right? So, using Pythagoras formula, we can find the value for h. Now we know that 10 square is equal to what? H square plus 6 square. So 10 square is equal, 10 square is 100, equal h square plus 36. Now, if we collect like times, you have that h square is equal 100 minus 36. That's it. 36 comes to this side, it becomes 100 minus 36. So I just interchange it. It's the same thing. H square equal 100 minus 36. So that our h square equal 64. If you take the square root of both sides, h equals square root of 64. and h is equal to what? 8 centimeter. Now, we have the value for our height. We can now find the volume of the cone, so that we have that volume is equal pi r square h over 3, which will give us our pi is 3.14 times our radius is 6 square times our height is 8 over 3. Okay, now 6 square is the same thing as 6 times 6. So we can have it as 3.14 times 6 times 6 times 8 divided by 3. 3 can go through 6 2 times, right? So that we have 2 times 6, 12, right? And 12 times 8 should give us 96, right? Yes, 12 times 8, 96. So we can find 3.14 times 96. 6 times 4 is 24. Remember 2, right? 6 times 1 is 6 plus 2, 8. And 6 times 3 is 18. Now, 9 times 4 is 36. So write 6, carry 3. 9 times 1 is 9 plus 3 is 12. We have 2 carry 1. 9 times 3, 27 plus 1, 28. If we sum it together, we have 4. 8 plus 6 is 14. 4 carry 1. 1 plus 8, 9. 9 plus 2 is 11. Remember 1. 1 plus 1 is 2. 2 plus 8 is 10. 0. Remember 1. The 1 plus 2 is 3. So we have 301.44, right? So this gives us 301.44 centimeter cube. Alright. Thank you for joining the class today. I hope you enjoyed the class. Please like, share across all your social media pages so that we can reach out to other students too who will need this teaching. If you encounter any challenge or any problem, reach out to me in the comment section and I'll be willing to respond to you ASAP. Don't forget that Goddard Maths Quest happens every Saturday on our YouTube page live. I'll see you in the next Goddard Maths Quest this Saturday and I'll see you in the next class. Till I come your way again, bye for now.